All right, let's dive right in. Have you ever wondered how an idea, something that just pops into your head, actually becomes something a computer does? It seems like magic, right? Well, today we're going to pull back the curtain and explore that incredible journey from human thought to machine instruction. Let's do it. Oh man, we've all felt this, haven't we? You've been coding for hours, you're sure you've nailed it. You hit that run button, and boom, everything just explodes. A screen full of angry red text. That feeling of why is exactly what we're going to tackle. We're going to turn that frustration into an aha moment. Okay, so here's the fundamental problem. We humans, we think in abstract ideas. Find the best route to the coffee shop. Show me pictures of my dog. Simple, right? But for a computer, no way. It needs brutally specific, step-by-step instructions. It doesn't understand anything. So there's this huge gap. And the story of coding is really the story of building a bridge across that gap. So let's get down to the absolute bedrock. At the very, very bottom, all a computer's processor, its brain, the CPU, understands is this, machine code. And what is that? It's just ones and zeros. That's it. A long, long stream of binary that tells the hardware exactly what to do. For us, it's complete gibberish. You can't write it, you can't read it. And that's our first giant hurdle. So what do? We can't speak in ones and zeros, and the computer definitely doesn't understand English. How do we even start to communicate? Well, the answer is one of the most brilliant inventions of the last century, programming languages. They are the bridge. But, not all languages are the same. It's kind of like a spectrum. On one end, you have high-level languages like Python or JavaScript. They use words and structures that feel pretty natural to us humans, which makes them way easier to write and debug. Then, on the other end, you've got the low-level languages like C or C++. These are closer to the metal, meaning they're much nearer to what the machine actually understands. They're tougher to write for sure, but they give you incredible control and speed. And that trade-off between easy to write and super fast, it has huge consequences in the real world. Just listen to what Facebook engineer Jackson Gabbard says. When you're building the foundations of a massive service like Facebook, something that absolutely cannot fail and has to be lightning fast, you have to go with those low-level languages. You need that raw power and efficiency. Now, if you're just starting out, don't let all this talk of low-level scare you. Here's some great advice from Google's Diana Goria. Once you learn one language, the next one is so much easier. It's because you're not just learning syntax, you're learning how to think like a programmer. The concepts transfer. That first language is the big climb, but after that, it's all about seeing the patterns. Okay, great. So let's say we've picked our language, we've written our awesome program in Python. We're still stuck, right? The computer still only understands ones and zeros, so we need another piece of the puzzle. We need a special go-between, a translator program that can take our human-friendly code and turn it into the machine code the computer can actually execute. And these translators really come in two main flavors, compilers and interpreters. Think of it this way. A compiler is like translating an entire book from English to French all at once. You do all the work up front, and then you have a finished French book you can read super fast anytime. An interpreter, on the other hand, is like having a live translator next to you. You say a sentence in English, they translate it to French, and your friend hears it. Then the next sentence. It's slower overall, but you get feedback instantly. If you say something wrong, the translator stops you right there. And believe me, this isn't just some boring textbook distinction. It has massive implications. Let's go back to that Facebook example from Jackson Gabbard. The site was originally built in PHP, which is an interpreted language. It's translated on the fly. But when you're serving billions of users, that on-the-fly part becomes a huge bottleneck. It's just too slow. So what did they do? Something kind of insane. They build a program to translate their PHP code into C++ code and then compile it, just to get that raw speed. And the result of that crazy project? It was mind-blowing. They could handle 4 times more traffic on the exact same number of servers. Think about that. That's the difference this stuff makes. Understanding the nuts and bolts of how your code actually runs is a superpower. So we've got our language, we've got our translator, but where does a coder actually work? You don't just use a plain text file. You need a workshop, right? A place that has all your tools in one spot. For programmers, that workshop is called the IDE.
That stands for Integrated Development Environment, or IDE, and it's exactly what it sounds like. It's one single application that pulls together all the different tools you need to write, test, and run your code. It's your command center, your all-in-one toolbox for building software. And a modern IDE is packed with goodies to make your life way, way easier. You get a smart editor that understands your code. It color codes things, suggests completions. It's like a spell checker for programming. You get your compiler or interpreter built right in, so you can run your code with a single click. And, most importantly, you get a debugger. This is your secret weapon for hunting down those inevitable bugs.
Which brings us to the, let's say, less glamorous side of coding. Because, let's be real, things are going to break. A lot. Writing code is one thing. Finding and fixing the errors, the bugs, is a huge part of the job. It's a skill, an art form, all on its own. And here's a fun little piece of history. You ever wonder why we call them bugs? Well, the story goes that back in 1947, the legendary computer scientist Grace Hopper was working on an early computer when it suddenly stopped working. After searching around, they found the cause. A literal moth had gotten trapped in one of the mechanical relays. They carefully pulled it out, taped it into their logbook, and wrote first actual case of bug being found. And the name stuck. So generally, bugs fall into 3 categories. First, you have syntax errors. This is basically a typo or a grammar mistake. You broke the rules of the language, and the translator just throws its hands up and says, I don't even know what this is. The program won't even start. Second, you've got runtime errors. Your code is grammatically correct, so it starts running, but then it tries to do something impossible, like dividing a number by 0, and it crashes. And then there's the third kind, the semantic or logic error. This is the sneakiest one. The program runs perfectly, no crashes, no error messages. It just does the wrong thing. It gives you the wrong answer. These are the most dangerous bugs of all. All right, let's see if you've been paying attention. I'm going to put a few lines of Python code up on the screen. It's supposed to ask for 2 numbers and then print the sum. Simple stuff. But it's broken. There are 4 syntax errors in there. Take a second, see if you can spot them. Go ahead and pause if you need to. Okay, did you get them all? Let's break it down. Number 1, input is misspelled as input. Classic typo. Number 2, the variable first is capitalized, but we defined it as lowercase first. Computers are picky about that stuff. Number 3, second is misspelled as sect. And finally, the string at the beginning of the print statement is missing its closing quotation mark. See? Simple little things that'll stop your whole program cold. An IDE would have screamed at you about all of these. But wait, here's the kicker. This is where those sneaky semantic errors come in. Even with all the syntax fixed, the code is still wrong. If you run it and type in 2 and then 2, it prints out 22. What? Why? Well, it's because the input function sees everything as text, not numbers. So it's not adding 2 plus 2. It's just gluing the character 2 and the character 2 together. The code runs flawlessly, but the logic is totally wrong. So how on earth do you find a bug like that when there are no error messages? This is where the debugger becomes your best friend. As Bill Sellers puts it, a debugger is like a microscope for your code. It lets you pause the program mid-execution and go through it one single line at a time. You can inspect all your variables, see exactly what the computer is thinking, and find that precise moment where reality and your expectations diverge. Look, all this stuff, languages, translators, debugging, it's not just academic theory for a final exam. In the real world, understanding these fundamentals is absolutely critical, because when you get them wrong, the consequences can be, well, let's just say they can be huge. Let's talk about Knight Capital. In 2012, this financial firm lost $440 million. Now, that's a lot of money. But the crazy part is how fast they lost it. It wasn't over a year or a month. It was gone in 45 minutes, all because of a single software deployment bug. And when you look at the postmortem, it's like a textbook case of what not to do. It was a complete failure of the fundamentals we've been talking about. They had different versions of their code on different servers. A technician manually deployed the software and accidentally activated a piece of old, bad code. There were no automated tests to catch it, and no kill switch to stop the disaster once it started. And that right there is the whole point. Look, pretty much anyone can learn the syntax to type out some code, but understanding the whole pipeline, how that code gets translated, how it's executed, and how to methodically hunt down bugs,
That's what separates a typist from a true software engineer. It's what allows you to build things that are not just cool, but also reliable, fast, and safe.
So I'm going to leave you with a little challenge. Think about your own coding setup. What's one tool inside your IDE that you know you could be better at? Maybe it's finally mastering the debugger. Maybe it's setting up the linter properly. Pick one thing and make a plan to really dig into it this week. It'll pay off, I promise. Thanks for tuning in.